Today, I'll be talking about algae-based biofuel. In this video, I'll be talking about the development, the impact, the analysis, and the plan for continuing this biofuel. Algae is a third-generation biofuel. They are photosynthetic organisms that produce large amounts of oils, carbohydrates, and biomass. They can double their biomass in a day, unlike other crops such as corn. Since algae absorbs CO2, they can grow almost anywhere, making it one of the most sustainable pathways to renewable fuel. There are three ways to cultivate this biofuel. The first is through open ponds, shallow raceway ponds stirred by paddle wheels. It is the cheapest method, but the most vulnerable to contamination and climate changes. Next is photobioreactors. These are closed transparent tanks that provide control over light, temperature, and nutrients. These systems are more expensive but high in biomass production. Third is algae grows from nutrients from wastewater, which helps clean water while producing biomass. This is known as the low-cost method that is also very sustainable. Now moving on to how this fuel is produced. We first start off with photosynthesis. Algae converts CO2 and sunlight into biomass. Biomass is then harvested, dewatered, and processed by lipid extraction, hydrothermal liquefaction, and fermentation. Moving on into the developmental status. This status is still in the pilot and demonstration stage. Dating back to the 1970s, we started with early research. As of As of the year 2000, it officially began the pilot studies. As of 2010, more demonstrations had started to begun. And as of 2020, upscale trials had begun. It is assumed that trials will continue to take place as time continues on. On to the carbon footprint. Algae absorbs CO2 while growing. This leads into potential low life cycle emissions. The greatest reductions while using the renewable energy is nutrient recycling and wastewater. However, poorly optimized systems can lose carbon benefits due to high energy use. Onto the economic impact. As you can see in this chart, the production cost for this biofuel is very high. And moving on to job creation, is frankly lower than the production cost, but it is still pretty high. As for the market value, it is skyrocketing high when compared to production costs. And finally, the research funding, which is slightly over job creation, but way under production cost. Public communication. Educating the public include campaigns, websites, exhibits, and school activities from biofuel companies and research institutions to teach the public about algae fuels. Their public engagement emphasizes pollution reduction and the reuse of wastewater and sustainable fuel goals. Unfortunately, algae is underrepresented in discussions of renewable energy. Analysis. The pros. Algae biofuel has incredible potential, high yield, low land use, and minimal carbon footprint. However, their cons, investment in photobioreactor technology, forming partnerships with emission-heavy industries, and supporting algae innovation hubs at universities and national labs. The ideal plan. For this biofuel, the ideal plan is unlimited funding, massive photobioreactor farms near near cost or industrial zones, integration with CO2 emitting factories, government funding for research and transport applications, and public education campaigns to raise awareness. Through unlimited funding, all these can take place and thrive. And lastly, these are my sources for this presentation.